This is Lab 1's calculations that we did. So these problems can be found in your workbook, and I'll just go over how to do them. So the first one is, how many centimeters are there in 1.5 kilometers? So first I'm just going to translate this sentence into a math statement. So we don't know how many centimeters, so I'll just put an X there. X centimeters is equal to 1.5 kilometers. Now I'm going to turn these letters into their math equivalent. So if you look on the first page of the lab, it tells you what these represent. So centi is 10 to the negative 2, and kilo is 10 to the third power. And I'm going to bring everything else down. So my X is still there, the unknown. My meter is still there, 1.5. Then I'll bring down this meter. Since meters on both sides, I can simply cancel this out. And now I want to get this X by itself. So I'm going to divide by whatever it's next to. And it's next to this, 10 to the negative 2. So get rid of this, get rid of this. Now let me rewrite the right side of my equation. 1.5 times 10 to the third over 10 to the negative 2. So I want to bring this up to the numerator so I can combine these. And how do you do that? You just switch the sign of the exponent. So what I'm left with is to the positive 2. And now since they have a common base, these two 10s, I can simply add the exponents. This is equal to 5. So my final answer is going to read something like this. We have 1.5 times 10 to the 5th centimeters is equal to 1.5 kilometers. And the way that this number is written right here, this is scientific notation. Okay, so here is number 2. How many millimeters are there in a centimeter? So again, we don't know how many millimeters, so I'll put an X there. So X millimeters is equal to A. A translates to 1 centimeter. Now I'm going to use my chart on the first page. Milli is equal to 10 to the negative 3, and centi, just like from before, this is equal to 10 to the negative 2. Everything else I'm going to bring down. X, meter, and then meter here. Since meters on both sides, I'm going to cancel this out. And now I want to get this X by itself, and I'll do that by using the opposite operation to get rid of that 10 to the negative 3. Gets rid of this, gets rid of that. So now this is what I'm left with. I want to get this 10 to the negative 3 in the numerator to make my life easier. You can simply do that by changing the sign of that exponent. So here's what I'll be left with. 1 times 10 to the negative 2 times 10 to the positive 3. And then now I can just add these exponents because it's a common base. So x is equal to 1 times 10 to the first. And this is just 10. So my final answer is going to read, you have 10 millimeters is equal to 1 centimeter. Yep. So here's number 3. It might look a little scary, but it's the same thing we've been doing before. So let me rewrite this. It tells us that there are 2.54 centimeters per inch. And we want to know how much is that in micrometers. So the symbol for micro is mu, and it looks like this, the Greek letter mu. And we use mu because the letter m has already been used by milli, so we can't reuse m. And we're looking for how many micrometers it's equal to. So since this per inch is on both sides, I can just easily cross it out. And now we're left with a similar looking problem from before. 2.54 centimeters is equal to, we don't know how many micrometers. So I'm going to change centi to its numerical value. This is 10 to the negative 2. If you look on your chart, micro is 10 to the negative 6. Everything else I'm going to bring down. So 2.54 times that, don't forget the meter, is equal to x times that. Let's not forget the meters. I'm going to cancel this out. Now I want to isolate this x, and I'll do that by dividing both sides by 10 to the negative 6. Gets rid of this, gets rid of this. So now let me skip a step, and I'll bring that denominator to the numerator by switching its sign. 10 to the negative 2 times 10 to the positive 6. So adding those two exponents together gives me 10 to the 4th. So my final answer is going to be 2.54 centimeters is equal to 2.54 times 10 to the 4th micrometers. And that's it. Okay, so now working with scientific notation. It says here I made $1,345,000 from selling students' organs. So how do I express this in scientific notation? So we can assume that this number right here is in a different kind of notation, and we call this standard notation. In standard notation. To turn this into scientific, we're just going to rewrite this number, and we'll put a decimal point right before the leftmost number. So this is what I have. You don't have to worry about the trailing zeros. Then multiply this by 10 to something power. To figure out that something, we're going to start from the right and count how many digits. So 1 digit, 2, 3, 4, 5, 6. We have 6 places. So this question mark is a 6. And we also can't forget the unit here. This is a $sign right there. So right now this is in scientific notation. Okay. So now on to reading a meniscus. So when you fill any kind of beaker, specifically a graduated cylinder, there's your graduated cylinder, you'll have the measurements on the side, and it'll tell you how much volume is in your graduated cylinder. When you fill this with water, however, it's going to form a little dip. So this is my water. And to read this, we don't read it here. We have to read it where that dip is. So approximately right here, this is where we would read it. And we call this point the meniscus. So read volume here. And what's happening is that this is composed of water molecules. So let me redraw this. So there are my water molecules. So H2O molecules. And there are two forces at play here. There is something called cohesion, and that's the attraction to other water molecules. So attraction to each other. And the second force at play here is the force of adhesion. And this is the force of attraction to the graduated cylinder. Attraction to the glass tube. Of the graduated cylinder. So at this point where the meniscus is, the force of attraction to the glass is greater than the force of cohesion. So we will say the force of adhesion is greater than the force of cohesion. And then thus a meniscus occurs. And that is it.